Hi there everyone, in this movie we are going to be looking at something called transition matrices. So here's a little setup for this situation, something that we should be familiar with, some tree diagrams. So we've got a really simple situation here that's saying if it rains one day the chance of it raining the next day is 2/3. If it doesn't rain one day the probability it does not rain the next day is 3/5. So we're going to include the probabilities on the branches and complete these situations. So if today it's raining, that means the next day the chance that it rains is 2/3. Alright, so this is 2/3, hence that's 1/3. Now if we look a day after that, if it's raining, that means it's 2/3 chance it's raining the next day. But if it doesn't rain, it says the probability it does not rain the next day is 3/5. So that is 3/5. And that is 2/5. Each branch must add up to 1. So if we do some calculations here, the chance of it, given that it's raining today, the chance that it's raining in 2 days' time, 4/9. That one's 2/9. This one here is 2/15, and this branch here is 3/15. And you'll find that they all add up to 1. So that's given that it's raining today, which it happens to be in this particular day. That's what's going on in 2 days' time. Now, if we're saying that it's not raining today, then the chance that it's not going to be raining tomorrow is 3/5. So 2/5 the chance that it is. And now if we look at the top row, if it's raining in day 1, there's a 2/3 chance it'll be raining the next day. If it's not raining, 3/5 and 2/5. Okay, you get the idea. So top one here is 4/15. Second one here is 2/15. This one here is 6/25. And the bottom one there, 9/25 if I multiply those probabilities. Okay, so let's transfer all this information into a simple matrix here. It's going to be called a transition matrix. We're going to start at the top from if it's raining today and not raining today, if it's raining in 2 days' time. Okay, so if it's raining today, and what's the chance that it's going to be raining in 2 days' time? So if we look at this tree diagram here, that is the sum of that probability and that probability there, 4/9 plus 2/15. So if you grab your calculator, 4/9 plus 2/15 gives us 26 out of 45. That is the probability right there. It's not a very nice number, but there it is. If it's raining today, what's the chance that there's no rain in 2 days? That is, in the tree diagram, this one and this one added together, 2/9 plus 3/15. So let's do that. 2/9 plus 3/15 is 19/45. And notice that those two probabilities will add to 1. Now let's look at the other one over here, no rain today. What's the chance that it's going to be raining in 2 days' time? Okay, so that is this probability. Well, let's stay with the red here. That is this probability and this probability added together. So 4/15 plus 6/25, and that gives us 38/75. It's a bit nasty, these numbers. And last one, what's the chance if it's not raining today that it is not raining in 2 days' time? So that is this one and this one added together. So 2/15 plus 9/25, 37/75. And of course I could have just said 1 minus this one here as well to get that, because each of those columns has got to add to 1. Now that's a bit labour intensive, isn't it? Here's an easier way. Suppose we took the initial information given the rain and no rain situation and created this matrix. So what's the chance that it's raining today and then it's going to be raining tomorrow? 2/3. What's the chance that it's raining today, therefore there's no rain tomorrow? 1/3. Chance of no rain today and there's rain tomorrow is 2/5 and 3/5. So that was the numbers given from the situation that we were given. So I've created this matrix from 2 for 1 day. Now the neat thing here is the transition matrix is what happened. If we call this matrix A, so 2/3 2/5, 1/3, 3/5. Guess what A squared does? When you square that matrix, you get these numbers here, and I've done it on my CAS. You get 26 out of 45, 38 out of 75, 19 out of 45, 37 out of 75. And you can see that is exactly what we got for this matrix here, where we did the whole big tree diagram way. A much quicker way. This is called the transition matrix, and you guessed it, it gets even better if you cube the matrix. That will be the matrix that represents what's going on in 3 days. Okay, so here's a few more examples of that kind of idea of the transition matrix. In this one here, we've got 3 brands of milk, A, B, and C, and people switch from one brand to the other. And we're seeing the transition matrix here from A at the top and to which brand we're going to switch to. So this first entry says that if you use brand A in week 1, there's a 0.7 probability they'll continue to use brand A. Okay, we'll go through everything, and I just want to get to this one here. So this matrix here is saying that if we start on brand C 1 week, the probability that we switch to brand B in the next week is 0.3. Now you notice here that the each column has got a sum to 1, because if we start in brand C, we're either going to go to A, go to B, or stick with C. So it's got to be one of those 3 things. So the sum of each column there is 1. So this is the transition matrix, and as I was just saying, the power of these things is to start talking about what's going on in 2 weeks, 3 weeks, 4 weeks, and even better, what happens in the long run. So, does this matrix settle down to what we call a steady state? So let's look at this one here. So the question is, if family is using brand B, what's the probability they're using brand A 3 weeks later? So what we do here is we cube that matrix T. We've called that T for a transition matrix. We cube it, and we get this matrix here. So this shows us that in the question, if we're using brand B, the chance that we will be using brand A 3 weeks later is 0.482. We can see that from the transition matrix cubed. Okay. Now this shows you the screenshots of how you would do that on your calculator, on your CAS. Okay, so define the matrix, put it into T, cube it, and your calculator gives it to you nicely. And then you just have to know which entry it is that you're looking at. In this case, it's that entry right there. Secondly, the local supermarket sold 500 jars of brand A, 350 of B, 430 of C. Use the transition matrix to calculate the expected sales of the brand next week. Alright, so we've got this other matrix M, which shows the numbers that we've done. To find out what we're going to have next week, we just multiply those matrices. We've got a 3 by 3 times by this 3 by 1, giving us this 3 by 1 matrix, which shows the sales next week. So 576 of A, 334 of B, and 370 cartons of C. And you can see here how you do that on a calculator by defining what matrix M is, and then just by multiplying them. Your calculator can handle that. Okay, so in this example here, we've got a population of people living in the city or the country, and we've got the initial numbers of the people living in the city there. The total number of people and the number of people who live in the city. And we've got this transition going on where 12% of those people that start in the country go to live in the city. So in this case here, we've got from down the left and to along the top. You can have either one. And the last one we had in the other way around. It doesn't matter which way you have it. So 12% of the people move from the country to the city, which means 88% stay put. And the question also says 7% of those people who start in the city move to the country, which means 93% of people who start in the city stay in the city. Okay, the question says, assuming the total population of the region remains at 857,000, that's a big assumption, but assuming the population doesn't change, how many of these people does the model predict will be living at the city, and how many will be living in the country in 5 and 10 years? Now, one important thing here to note is that surveys suggest in a period of 5 years. So this transition matrix here is covering a period of 5 years. So it's important that we understand that. So when I just do this matrix times my initial numbers, that's giving me the numbers of people after 5 years, not per year. Okay, so to answer the first question, on our calculator we would just substitute this matrix in for T, let's say. So the answer to A is just the matrix T times by, in this case here, the numbers of people in the city, 640,000, in the country, you just take the total number and minus 640,000, giving you 217,000. When you do that on your calculator, you would get 621,000. This wants it to the nearest thousand, and 236,000. Okay, what's going on in 10 years' time? In other words, that's 2 periods here. So that's just T squared times our initial numbers, 640,000 and 217,000. You could either write this matrix out or define this matrix here as matrix M and then just go T squared times M. So if you do that to the nearest thousand, you get 606,000 and 251,000. Alright, as I was saying before, the interesting one is B. In the long term, what percentage of the population of this region will live in the city and what percentage will live in the country? Okay, so we're going to go for our steady state thing going on here. So if you go T cubed, that will be 15 years time. T to the power of 4 will be 4 cycles or 20 years. What if you went T to the power of 30? 150 years times by our initial matrix M, which is this one here. You would find that if you did that, you got 504 to the nearest thousand, 541,000 and 316,000. And in fact, if you did T to the power of 50 or 60 or 70, you would get the same thing. Alright, so after a while, we know that the numbers are going to be settling down to those numbers there, and hence we can work out the percentages. If we just focus on that matrix itself, you'll see that when you do T to the power of 50 or 70 or whatever, you get this 0.63, 0.37, 0.63, 0.37. Okay, so you can see that the matrix has settled down. So if I do power of 70, you'll get the exact same thing. Okay, so you can see, remember this was from 2 and this was the city up here. So you can see that 63% of people are going to be living in the city and 37% of people are going to be living in the country. Okay, really it's this way here that we're looking at. Okay, we're looking at the 2. So 63% in the city and 37% of people are going to live in the country. We also could have worked that out just by looking at these numbers here and working out what percentage 541,000 was of the total number. That would also give you 63% of the total.